What is the probability that this artifact will roll all 4 rolls into crit? How about specifically 2 rolls into crit rate and 2 rolls into crit damage? If you ever rolled artifacts in Genshin Impact, chances are you know that this can be quite difficult. But have you ever wondered what exactly those odds are? In this video, we will go over all the possible outcomes when rolling artifacts. We will also go over how many rolls you can expect will go into relevant substats like crit damage and crit rate. So without further ado, let's get started. First, we need to go over some of the relevant basics for artifacts. All artifacts are composed of a main stat and 4 substats. Once the main stat is selected, 4 unique substats are generated from the following pool. Leveling an artifact every 4 levels will increase the main stat value, while one of the 4 substats will have a chance to be upgraded. This process repeats until an artifact reaches level 20, the max level for a 5-star artifact. Additionally, artifacts can also generate with 3 or 4 initial substats, which we will refer to as 3-liner and 4-liners respectively. An artifact that is 3-liner will reveal the 4th substat at level 4 instead of getting an upgrade roll. This means that a 3-liner will have 4 chances to roll upgrades, while a 4-liner will have an additional upgrade roll. Now that we have covered the basics, let's take a look at some 3-liner artifact outcomes and determine their probabilities. There are 4 possible substats to roll and 4 chances to roll. So, if we multiply 4 times, this gives us 256 possibilities. Let's take a look at the 3-liner artifact that was just rolled. What is the probability that all the rolls went into attack percent? In this case, there is only one possible scenario. At each upgrade level, the roll goes into attack percent. This means that you would need to achieve a 25% chance 4 times. This turns out to be a 1 in 256 chance, or 0.39%. Of course, attack percent is not the only substat that can be rolled into 4 times. The artifact can roll 4 times into crit rate or crit damage or elemental mastery, with each possible outcome also having a 1 in 256 chance of occurring. Let's say our next artifact rolled like this. 3 rolls went into crit rate and 1 roll went into energy recharge. We would picture that this outcome would be easier to obtain, but by how much? One possible case is that crit rolled at levels 8, 12, and 16, but that is not the only way. This can also be achieved by rolling crit at levels 8, 12, and 20, crit at levels 8, 16, and 20, and so on, resulting in 4 cases. So, for this specific outcome, the probability would be 4 in 256, or about 1.56%. What we have essentially done is list out the different permutations for this roll outcome. In other words, we determined how many different ways or arrangements can achieve the same outcome. For now, we only looked at a simple outcome with only 4 permutations, so our next question may be, how many permutations are there for the most common 3-liner outcome? To answer that question, we first need to look at factorials. You may have learned what a factorial is from math class, but just in case, here is a quick overview of the factorials we will be working with. Factorials can help us determine the number of distinct ways to order objects. For example, let's say that you have Nahida and Raiden on a team. Nahida can be the first slot, followed by Raiden, or Raiden can be the first slot, and then Nahida. This gives us 2 factorial ways to arrange the team composition, which is 2. Now if we add Furina onto the team, she can either go into the first slot, second slot, or last slot. This gives us 6 different ways to arrange the team, or 3 factorial ways. Repeating this pattern with Kale as our last character, we can see that there are 24 different permutations to arrange for distinct objects. In the context of Genshin artifacts, each character can represent a substat on the artifact, with the columns representing each of the 4 upgrade levels. This outcome specifically represents an artifact rolling into each substat once, which has a 24 in 256 chance of happening, or a 9.38% chance. We can also use factorials to determine all the possible outcomes for a 3-liner. There are 5 different roll cases to examine. A 3-liner can roll 4 times into one substat, 3 times into one substat, and only once into another. 2 times into 2 different substats, and so on. We previously saw how there are 4 cases for an artifact rolling 4 times into one stat, but to determine other cases, we will need to go back to our character arrangements in a team. Let's say this time we only care about the type of element that is in each slot. The first thing that we notice is that there are some repeating permutations. If we take a look at these 2 cases, both have a Dendro character in the first and second slots, Hydro in the third slot, and Electro in the fourth slot. The main difference is the slot that Nahida and Kale are in, which can happen in 2 ways, or rather 2 factorial ways. To account for all the repetitions, we can divide 4 factorial by the 2 factorial ways to order the Dendro characters. This leaves us with 12 possible outcomes. Now for each element, we can assign a number: 0 for Dendro, 1 for Electro, and 3 for Hydro. And voila, we have all 12 roll outcomes that rolled 3 times into one substat, and only once into another substat. Similarly, we can assign the numbers: 1 for Dendro, 2 for Electro, and 0 for Hydro. This will get us all the possible roll outcomes for an artifact that rolled 2 times into one substat, 1 time into 2 different substats, and 0 times into the last substat. For the last 3-liner roll case, plugging in the factorials will give us 6 possible outcomes, which we can verify quite quickly. Now, the only thing we need to do is determine the probability for each roll case, and you have probably guessed the tool that we are going to use for that. Previously, we determined the probabilities for 3 of the 5 cases. We can verify that these are correct using the factorial calculations we talked about. Essentially, we are taking the factorial of the total number of rolls and dividing that by the number of times each substat was rolled factorial. Doing this for the other cases will give us the total number of permutations for each outcome. If we sum up all the permutations, we can see that all 256 possibilities are accounted for. With all the outcomes and probabilities, we can now determine how many rolls you can expect to roll into your relevant substats. If we consider the first column to be the relevant substat we want, we can sort through all the cases from 0 to 4 upgrade rolls. There are 81 ways to roll no upgrade rolls, 108 ways for 1 upgrade roll, 54 ways for 2 upgrade rolls, and so on. Plotting this as a probability density function, we can observe that the most common outcome is 1 roll. So if you picture we are trying to roll a 3-liner crit circlet, you can see why it can be very difficult to get even 2 rolls of crit. That probability would be the sum of getting 2, 3, or 4 upgrade rolls. This will give us 67 in 256, just a little more than 25% of all the possibilities. Similarly, we can sort through the first 2 columns to represent the number of times an upgrade goes to 2 relevant substats. We end up with a more symmetrical distribution, with the most common outcome being 2 rolls at 96 out of 256 possibilities. Closely followed is 1 roll and 3 rolls, both at 64 out of 256 possibilities each. Lastly, there are the all or nothing scenarios, which are at 16 out of 256 possibilities each. What we can also do is break down how many rolls go into each of the relevant substats. For example, for 2 upgrade rolls into relevant substats, that roll could either go twice into crit rate, twice into crit damage, or just once into crit rate and once into crit damage. This divides the 96 possibilities into 4 parts. For 3 upgrade rolls, there are 4 different cases, with each case having 2 possible outcomes. For example, when rolling twice into crit rate and once into crit damage, these 2 outcomes give us 24 out of 256 possibilities. This probability is also the same for the case with 1 roll into crit rate and 2 rolls into crit damage. Lastly, for 4 upgrade rolls, there is only 1 possible outcome, so we do not need to sum any additional cases. Going back to the example I showed at the beginning, the probability of rolling twice into crit rate and twice into crit damage would be 6 in 256, or 2.34%. And there we have it, all the probabilities when rolling into 1 or 2 relevant stats. For a 3-liner at least. So, if there is anything that you should take away from this video, don't roll 3-liners like this. Unless you know what you are doing,